Let's do a quick review of exponential properties. Actually, the first thing I want to do is point out the difference between exponential functions and power functions. The reason I want to point this out is that these properties of exponents work for both types of functions, but nevertheless the functions themselves are very different. So an exponential function has something like f of x equals b to the x, where this base is a constant and the variable here is in the exponent. And a power function is something like g of x equals x to the a, where now the exponent is constant and it's the base that's the variable, and the input is the base. So everything I'm going to show you works for either type of exponent, but the functions themselves are very different. So now that we've seen that, let me just delete this power function since we're not really going to be working with that anymore. So these exponential functions, f of x equals b to the x. So our first useful property is that b to the x plus y equals b to the x times b to the y. Now the easy way to see that is just to test it with a couple numbers. If you look at 2 to the 3 plus 1, well, that should be 2 to the 4, and we ask ourselves, is that in fact 2 to the 3 times 2 to the 1? Well, 2 to the 3 is 2 multiplied by itself 3 times. 2 to the 1 is 2 multiplied by itself once, and so yes, in fact, you do get 2 to the 4th. And in here, again, to emphasize, what's going on is we're changing what these exponents can be rather than changing what the base is. Alright, some other reminders. If I want, let's say, b to the minus x, that's the same thing as 1 over b to the x, because a negative exponent is the same as putting the whole term in the denominator and making the exponent positive. So our example could be 3 to the minus 2 is 1 over 3 squared, which is 1 over 9. Another property is just remembering that you can kind of combine these. So I can look at b to the x times, say, b to the y, and divide the whole thing by b to the z. And what I actually get is b to the x plus y minus z, just by using these previous two properties. The multiplying of these two terms adds the exponents, and then dividing by the third term subtracts the exponent. Alright, the next property I want to talk about is if we take b to the x and then we raise the whole thing to the y, that's the same thing as b to the x times y. So the easiest way to see this is again through an example. So if we take, say, 4 squared and then cube the whole thing, well, that's 4 times 4, and then I've cubed it. So I do that and multiply them by itself 3 times. There's 4 squared, and then 3 of them multiplied together gives me that 4 squared cubed. Well, I can drop these parentheses because I'm multiplying all the way across. That's 4 times 4 times 4 times 4 times 4 times 4, and that's 4 to the 6th. And notice 4 to the 2 times 3 equals 4 to the 6th. So it's easy to see why this notation makes a lot of sense. Okay, those are the three properties that I wanted to review, and there are a few more, but they mostly kind of come from those three properties. Let me just write them down one more time to have them all in one place. So if you have b to the x plus y, that's equal to b to the x times b to the y. If you have b to the minus x, that's equal to 1 over b to the x. And if you have b to the x and then all of it's raised to the y, that's equal to b to the x times y. Now the other thing I want to highlight is that these properties work in both directions. So you can go back and forth. You don't always go left to right. There are frequently times when you want to write something that looks like, b to the x times b to the y, you want to write it as the sum of the exponents. Likewise, the second property and the third property, they work in both directions. And so I don't want you to get stuck always thinking of it in a left to right sort of idea. You should really be able to see this as equivalency rather than the direction you should necessarily take. Let me just give you an example. If I look at, say, 1 over 2 to the minus x, this is a little confusing because that's not 1 over b to the x. There's a minus there. But see, I can write that as 2 to the positive x because this is 2 to the minus x. And there I've just gone in the opposite direction. Right? I've gone from the 1 over b to the x to a b to the minus x. And actually, I've really simplified the expression I have. Very complicated expression is what I started with, and I've been able to write it as a very simple expression because of this flexibility and seeing these properties as equivalencies rather than a directional path that you have to follow. All right, I hope that will get you set up for working with the exponential functions that you'll be seeing in the future.